Okay, sorry, let's start again. The internet is really driving me crazy. It's fine when it works, but it just want to drop when it drops, I don't know why. Yeah, it's really bad, my internet provider. Yeah, really angry. Let's get this done. I am getting tired because of this internet problem. Yeah, if you know how to fix the internet problem, let me know. I just, it's a big headache for me. I've been like, fighting with the internet provider for a long time. Yeah, so let's move on to the last bit of the chapter 4. So, yeah, it's a bit mind blowing. So basically, the ownership, if you pass, then if someone owns it, you can do it by pass by reference, like that. You can pass it like this, and then you can, you still have S here. So take ownership now. It doesn't take ownership. If we add the N here, then it should okay, let's rewind a little bit. Yeah, it should be an N here. Then it should be a reference. So now if we do this again, then it should work. You can either pass it back, or you can pass by reference. But if you want to change something, then I need to pass by mutable reference. But the problem is you can only have one mutable reference at any time. So this is recap what's going on here. At any time, you can only have one mutable reference or unlimited immutable reference. You can't have a mutable reference and then use the immutable reference before, then it doesn't work. And 1 second, let me close. Sorry about that. Yeah, all the reference must be valid. You can't have something that passed by reference and then drop it after. It's very complicated, but hopefully the compiler will help you to guide you to fix your problem. So what's going on here now is that we would have a slice type. So it's a new thing. Slice is kind of a reference, but it does not have an ownership. So what's going on? So it's write a function that takes a string of words separated by spaces and return the first word. If the function doesn't find a space, then the whole string will be one word, then it will be returned. So if we write the function, so it will have a first word, it will have a string. We don't want the ownership, so we just pass by the reference. So it's something. We have a way to talk about part of a string. Return the index of the end of the word. So let's do that. So we'll be returning a number. So spikes equals s of spikes, and then for I and an item, blah 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 blah. So we check element by element. That if the item is a space, then we'll return the index. This one is enumerate, so it would just like go through the bytes. So as a spike, so it will be like each character, and then each character will have an item, and then we check whether it's a so also by reference. And then we check whether they're the space. All right. Okay. Yep, element by element, so we need to use a spike method, and then after that it's the iterator, iter is a method that return each element. Yeah, but we don't want to pass the ownership, right? So that's why we use the reference. It's the reference to an element. Okay. Single by reference, yep. For loop. Now, there's a problem. We return in the size on its own, but it's a meaningful number in the context of the end string. In other words, because it's a separate value, there's no guarantee it will still be valid in the future. Yeah, so if it emptied the string, then the number it got returned doesn't really mean a thing. Yeah, no string to reference to. So, Before any errors, you should do if you use the word after calling. Yeah, so if we reference, then of course we have a problem, because, like, you know, if it's empty string, then it doesn't have the index 5, but yeah, so this is still valid until we access it. So how can we make them like related? Still things the value of 5. I've been worried about indexing word getting out of sync. And yeah, so this is a huge problem. The second word. What if we have a second word as well? Oh my god. The start and the end. So yeah. So if we can use slices, then it will be better. So this is the reference to S, but this is like 0 to 5. So I guess it's not inclusive of 5, so it's 0, 1, 2, 3, 4, right? So it's not inclusive of the 5. Yep, so S would be this, and then row will start with 6. So here, and the length will be 5. So like this. Okay. So you have the dot dot range syntax. So you have the 0, or you can omit the 0. And then yeah, you can also drop the n, which will be the end of the thing, because it's known. Yep, so this is the slice, and then yeah, so there's also the boundary. You can't slice something that is not sliceable. So yeah, so for example, if you want to slice in the middle of a character, then you can't do that. So if a string size is n string, so that's what we have seen yesterday, n string. So yeah, so this will return a slice. Oh, okay. Okay, now I'm more clear about what's going on here. Now I can return a slice. I can return this slice of a string. So return, otherwise return the string itself, full range. So, but this is only a reference. Like, it's the same, still the same thing, but it's just referencing anything inside it, right? So, okay. It's tied to the underline. Yeah. Much harder to mess up. This one got a problem because this one will have an error. Word, because word is a slice, so if you clear it, then the reference, the reference, the string reference, the reference word, because it's a slice, a reference to a string, so it got reference, and you can wipe it out. I think error. Yep. Mutable borrow occurs here. So yeah, because it's immutable borrow, and then now so the word is an immutable borrow, and now you change it, and then you reference it again. So no. We can also take a mutable reference. Clear is a truncate string. You need to get a mutable reference. Yep, so this is actually a mutable reference. This is a mutable reference, so nope, not allowed. String literals are slices. Type of S here is what's being stored inside the binary. Now know that slices. So all these actually string literals are actually n string because they are sliced within the library, the binary. And also why string literals are immutable, because this is a mutable reference. Now it makes sense. Take sizes of literals and strings. If we have a string slice, we'll pass it directly. If you have a string, we can pass a slice of the string or reference of the string. So for example, I have a my string, then you can pass it as a slice. If you pass it the full thing, it's a slice of the full thing, so it will still pass in here. Yeah. This will also work as long as it's a reference, I guess. Or you can just pass in like this, because this is already a reference. Okay. Other slices. So you can also slice an array like this. Yeah. Also do that. Here's the type. It's the same way. Okay. That's set equal. So it's just 2 and 3 by reference. Yep. Okay, so that's cool. Now we kind of clear up a lot of things that I'm not sure before. And yeah, save the program. So chapter 5 talk about structs, which is another new concept, I think. But yeah, this is cool. This is fun. Just just kind of like break down how string work and how like the ownership of Rust would affect like how you got things passed in as reference or something like that. And yeah, and also the slice. I think this is cool. So shall we move on? Actually, my internet is going good right now. It's crazy. Like, I'm very tempted to move on. Let's take a break, and I would decide if the internet is still good. Maybe we can move on. We'll see. Yep, let's take a break. Okay, back to chapter 5. Using struct. So structure related data. So custom data type. It's like data type. Group them together. They're like data class in Python, I think. Yep. Data attributes. Structs and enum. A method. Okay. It's kind of similar to object-oriented programming. Similar to tuples. Name each piece of data. It's like data class, no? So we use struct. Describes the significance of the piece of data being grouped together. Inside we use curly brackets to find the names and the type of fields. Yeah, this is actually super handy, I think. We can create an instance as well. Key value pair. For example, if user 1 there is a user and then okay. Okay. Yeah. Yeah, it's like data class, but yep, use it like that. Use dot notations. If it's mutable, we can use dot notation to change it. Okay, because it's mutable, you can change it. It's fine. And high instance must be mutable. You can't just like one field is mutable, but the other's not. Okay, so build user function. It takes a, so it will return a user struct, a user instance, and then yeah, it will return a user instance. Okay, by using the email and the username. Right. Okay. Makes sense to name the function parameter with the same name as the struct field. Like username. Yeah, username field is tedious. You can do it like that. Shorthand. Okay. This is handy. I like it. I hate doing it twice. Sometimes, yeah, it looks silly. It types silly. It's silly. Creating instance from another instance with struct update syntax. So, this is user 1, so we can get user 1's value and then put it into user 2. So we can copy it over like that. But then user 1's username has been moved, right? Yeah. What about user 1's username? I'm confused. We created using struct update syntax. We can achieve the same effect. You just use .user1. So using user1 as a base and update the email. Okay. Yeah. Yeah, I really wonder, like, if it's this, then user 1's username is gone, right? Okay, I want to test it out. Let's do that. Let's do this. Right. Okay. So maybe I should create a new one. Oh no. New. And then here to the main, I can copy this. I guess I can copy this. Oh no. And then I can copy this, right? Email is never. Oh yeah, it's just the underscore thing again. It's fine. I can underscore them. It's not a big problem. Now the name needs to be changed. It's fine. I hope there's a flag that I can like ignore that unused thing. Email is field in this struct. Email. Why is it only complaining about email? It's never read. Oh, because this is red. This is okay. Email is a unique. More than one user can have the same. Yeah, email is a unique thing, so you can. But now I can't really like run this. How about I run it here? Can I see what's going on? No, I'll put yeah, I just want to see like what's going on with user 1, because like I've the username of user 1 is now passed on, right? So if I call it again, will I get a thing? Will I get another warning about it or whatever? Yeah, it's borrowed. So if I do that, then user 1 is basically invalid because I've copied this over, and it's, you know, like then the username is user 1's username is not supposed to be used again. So interesting. Anyway, let's overlook it and move on and just tell me that I can use this, which is fine. I guess I can like delete all this and then do a dot user 1, something like that. All right, no space. Yeah, but it will have the same problem here. If I remove this, then it should give me the, yeah, it's dead code. Yeah, it's unused. Yeah, I know. Anyway. Okay. So 1 user 2. So create instance, different value. Yep, same value. Struct update syntax use equal like assignment. Yeah, no longer use user 1. I am already like thinking ahead. Yes, because user 1 is copied. The ownership is shift E. So yeah, no longer valid. So basically user 1 and user 2 is the same person. It's just update the email, I guess. So because you keep your username, otherwise like you need to be unique. Yeah. Only use active income value from user 1. The user 1 should. Yeah, so if they are both new, then I can, then like for example this, then of course now we have that error again that is always borrowed. But what if I also give us a new username like that? Now some username 123. Now this is 456. Let's say. And then now it should be fine. You just go back to the dead code warning, which is okay. And I can have some username 123. Okay, cool, nice. Okay, tuple struct without name field. I can also create a struct without a name field. It's just like a normal tuple, but with a name associated with the tuple. Tuple structs like this. Yeah. Okay. This is fine. Use a dot followed. Dot followed by the index. So for example I have this, then I can have print and now I am super familiar with this. Now I've typed it so many times. I can have black dot 0, then I would get 0 back. Well, this is all 0, but anyway. Yeah, exactly. There's a lot of warning. Yeah, they are not used. I know, it's fine. Yeah, and unit like struct with any field. You just always equal. Without any value. Why do you do that? Unit like struct because they behave similar to just a bracket unit type. Huh. Chapter 10 we'll see more why. Okay. So we create an instance of always equal. No need for curly brackets or parentheses. So you can implement the behavior of this in probably chapter 10, but there's no value associated to it, so you can just create an instance like that. Yeah. Okay. It's just always equal no matter what, so it doesn't need value. So in chapter 10 we'll know more. We'll come back to this. Ownership of a struct data. So yeah, we own our own data. This is by default, but by design. But you can also have it referenced like that. So reference to data owned by someone else, but to do require the use of lifetime. Also, chapter 10 we'll talk about that. Lifetime ensure the data referenced by struct is valid for as long as the struct is. Let's say you try to store a reference in struct without specifying the lifetime, like the following. This will have a problem. Because this is referencing something in the binary. Expect a lifetime parameter. Yep. So in chapter 10 we'll solve this problem, so don't worry about it right now. Chapter 10 is a long way away, so don't worry about that. Using struct, a program using struct. Your binary project it's called rectangle. So calculate the area of a rectangle. We start by using a single variable, and then they will refactor the program using the struct. So let's create a new project. Go new rectangles. I am horrible with spelling, so I don't trust myself. rectangles, rectangles. Rectangles. And then what are we doing here? Well, let's copy this first. Rectangle. And then let's clear off some of this clutter things, and then we would do this. So we have a height and width, and then the area will be area of height and width. So area will do this calculation here. Okay, I guess we can use the struct for the rectangle. So what are we doing to do? So if we run, it should run. Right. Okay, we have the with the correct result. Okay. Calculate area. Where are it related? Okay. Yeah, we want to use a struct. So what do we want to do is to, we can also make it as a tuple like it does here. Instead of height and width, we just have this rect one. Dimension 0 and 1. So it doesn't matter which one is height, which one is width, so we can do that. This will also work. Yeah, but with more meaning. So for example, we can create a rectangle struct, so we can name it width or height, width and height. Right, so now we can name it, and then we create rectangle one with the specific of the width and height, and then we can use dot width and dot height. So this is more obvious than just like whatever the two thing is. So it's just making the code more readable, I guess. Cool. Oh, we also have to use the N because right. Borrow, because we don't care about yeah, we just want to reference it, right? Otherwise rectangle 1 will pass the ownership. Yeah, does not move the view values. Yeah. Which is an immutable borrow. Yeah, we want to borrow rather than taking ownership. I think this is like the pitfall, right? People keep forgetting about this all the time, like me. So we have that. Rectangle 1 is rectangle 1. This have a problem because this one doesn't have an implementation, yes, of display. So use format known as display. Yeah, so like for example, integer and string is quite straightforward for the display, so it will work. But for a struct, because it's a new struct and there's no way the display knows about it, so it doesn't know. Doesn't try to guess. So you have to provide a implementation of display, I guess. Yeah. The print line marker. Okay. So what should we do now? So. Okay. It's not implemented, so we have to implement this, right? Or pretty. Look at, so the macro call will now look like colon question mark. The debug trail enable us to. Oh, now they're talking about debug. I think someone mentioned it yesterday. So now let's give it a play. So if we now use colon question mark here, what would happen? Okay. It's like enable us to print our struct in a way that is useful for developer. We still get an error, yes. Doesn't implement a debug. It's not implemented. Nothing is implemented. Display is not implemented. Debug is not implemented. Functionality to print out debug information. So what should we do? So we can write something about debug. Outer attribute. Defer debug just before the struct. So let's do this. What does this do? We won't get any error. Huh. Okay. We still got the unused warning. Huh. Interesting. Ah, because you have to. No? That's fine. Better of all fields in the instance will definitely help during the debugging. You can also use this one for 3D printing with the hash sign. Let's try that. Okay. Yeah. Print out the value using debug format is to use the dbg exclamation mark macro. It will take the ownership of the expression. Print out the file line number and where the debug macro go. And then return ownership. Standard error as opposed to inline standard output. Okay. So now what are we doing? We have the scale equals to 2. Rectangle, we have the debug, so we can debug this time scale. Okay, let's see what it does. And here we will have, so it will print out this equals to 60. So this will give you an output for this. And then it will give you the output of this as a debug output. Okay. Cool. Get the same value if we didn't. Okay. Yeah, we don't want it to take an ownership, so then we use n. Yeah, use pretty print format. Okay. The ref attribute can be useful behavior. So chapter 10 we will talk more about it. Here have the derivative attribute. Okay. Let's not look too much into it. We'll save it for chapter 10. Area function is very specific. Only compute the area of rectangles. Yeah, so what if area want to work with more than one struct type? What shall we do? Cool. Let's move on. Method syntax. So now we have rectangle. We'll have method within rectangles because like this area method is specific to rectangle, so we want to attach it as a method to rectangle struct. So it's a IMPL rectangle, and then inside there's a function that is okay. I think this is pretty straightforward so far, but we can maybe see the the explanation. So an implementation block for rectangle within this will be associated with rectangle type. The area function, we put that in there, and goes now we have to rec1 the area. Okay, So now we have the reference self here. Cool. Yep. And right. Dot width. There's a non-zero width. What's going on here? With associate, yes. We use and self, yes. Providing method. So we can also have a width. Okay. So if width bigger than or equal to 0, it will just return a boolean of yeah. Okay. Often but not always, we give the method the same name as a field. Want to only return a value in the field to do something else. Getters, yeah, exactly. Does not implement them automatically for struct field. Some other language do. Getters are useful. Read only access to the field. Yeah, right. So it doesn't automatically. So the width here is not automatically a getter thing. So you have to implement something yourself. That is with the same name, and yeah. The arrow operator. Okay. Calling a method on an object directly in an arrow. If you're calling the method on a pointer to the object, you need to reference the pointer first. If object is a pointer, object arrow something similar to dereference object something. Okay. Yeah, in C and C++ you have those two, right? And if it's a pointer, then you use the arrow. Yeah. Right. Rust doesn't have the arrow operator. Instead, automatically referencing and dereferencing. Method automatically add n mu or star, or so the object matches the signature. Yeah, so you don't have to worry about these whether it's like a pointer or a reference. Like this is really like confusing in C and C++, which my memory is coming back. my memory of learning C and C++ is coming back. Yeah, I remember all these, like, oh my god, the N and the star and the arrow. Oh my god, like, why are they so different? And you have to always keep track. Your mind have to keep track of what are you trying to like talk about. Like, what is this thing? Is it a pointer? Is it like a thing? Or yeah. But Rust take care of it for you. So you just always dot something. Yeah. So it looks much cleaner. It won't be very confusing for beginners. And yeah, figured out is it n self and mu self or consuming self? Borrow. Yeah, I guess like you don't have to keep track of what it is, but if you made a mistake, then the compiler will probably tell you. Method with more parameters. Whoa, okay. So now we have 3 rectangles, and then can hold. So take another rectangle and compare it to itself. So it will return true or false. Yep. Also, n is nn. Okay. Take in the reference of the other, and then compare. The width n, so it needs to be smaller. So the other's width and the other's height need to be both smaller. Yep, we just add it after n self. This is pretty straightforward. Associate functions. All functions defined within the imp block are called associated functions, because so it's, it's called associate, but it's also called methods sometimes for other languages. I don't have south, huh? So you don't need south necessarily. And they're not methods. Okay. It's kind of like a class method, right? Yeah. It's not associated to the instance of it. It doesn't have self. Yeah. Yeah, I guess this is more like a class method. It doesn't like associate with the instance of it. Yeah, again, I'm making a lot of Python reference because I am a Python programmer and I'm learning Rust. Yes. It's called new. So there are also like new associate function AND method are often used for constructors. Yeah, like a new in Python. Return a new instance. For example, like it's called new. It's a special name though. It's inbuilt into the language, so you can call it something else. You can call it, whatever. Name square. Yeah, you can name it square, and then you will provide a square that with that the size. It will create an instance of self. Oops, sorry. Sorry, Docker. I'm not updating you right now. Yeah, so it's so yeah, it will create a self. So basically it's a new, this one, but it's called square. So yeah. What's the colon syntax? So rectangle colon call this associate function. Yeah, I would just make a mental note. This is like class method for me in Python. So it's like colon square 3. It may be not exactly correct, but for me it's like how to help me understand what's going on here. Yeah. Yeah, we'll discuss that in chapter 7. I think I'll have a better understanding. But for now, I'll just treat it as a class method, I think. Like, yeah. But, okay. Multiple imp block. So you can have more than one. Yeah, like that. So you can have area, you can hold, you can write it separately. No reason to separate this method in the multiple imp block here. I guess you can put them into one imp block, but yeah. But you can still do that if you want. We'll see a case in which multiple imp blocks are useful in chapter 10. And we will look at that later. Yeah, cool. Struct, I love it. It's very cool. It's kind of similar to like class, or data class or class in Python. And it's cool. It's yeah. So yeah, I think this is useful. Now we can write like a lot of complicated things with all this knowledge. And yeah, so I think this is it for me for the daytime. I will come back in the evening. Hopefully the internet is being nice to me again. Like, sorry about earlier today. I still don't know why my internet want to play up. Sometimes I have to investigate, maybe change the provider, whatever, to make it work. So sorry about that. Thank you for sitting together with me to go through all this Rust journey, and we'll go to Enam next time for pattern matching, and which is cool. So maybe later today or tomorrow, I don't know. Again, I don't have a schedule. I am also doing a lot of community work at the moment. Also, find a new job because I can't be jobless for a long time, so I have to really put myself to work. And but it's fun learning new things. I love learning new things, and it's always fun to do that with people, because I see a few people are watching and few people comment. So thank you so much if you have watched and comment. I think it really helps. So far everybody have been so helpful, giving me tips and stuff, which is I feel like very supported. I'm so happy. And yeah, so that's it for me. Have a nice, if you're here in this part of the world, have a nice afternoon, or I don't know where you are, but have a nice time. I will see you back in less than 24 hours, I hope. So okay, see you. Bye bye.